Okay, in this video we're going to look at how to calculate the magnitude of a vector in R2. So again, I want to keep going back, I forgot my X there. I want to keep going back to that phrase that you know more than you think you do about vectors. So what I've got here, this is something you would have been probably first taught in grade 10. The distance formula based on the Pythagorean theorem for the distance between 2 points. That's what we're going to use for vectors. So notice here I've got a point A I've labeled, that's 2, 3, and then the point B, which is 5, 5. So let me check that. 1, 2, 3, 4, 5. 1, 2, 3, 4. Yeah. So if I do this, if I have the tail at A and then do this, like this right here is a vector, right? As soon as I go from tail A to head B, that is the vector AB. Now, what are the coordinates of AB? Well, what we want to do is we want to look at what we've got here. x2 minus x1, y2 minus y1. So I'm going to write here, we know that delta x is x2 minus x1, and delta y is y2 minus y1. So what I like to do when I'm getting these coordinates here, so I'm going to put down whichever one I saw first, which was the tail A, and then the head B. So we can go x1, y1, x2, y2. So we do delta x, which is x2 minus x1, that's going to be 5 take away 2, which is 3. And then we do delta y, which is y2 minus y1, that's going to be 5 take away 3, which is 2. So that is the coordinates of the vector 3, 2. Now 3, 2 itself, if I were to plot that, so I'm just going to change the colors here. Starting at the origin, 1, 2, 3, and then 2. So 3, 2 is what they call the related position vector, because that one does start at the origin. So the related position vector is the coordinates of something like this when you're not starting at the origin, like you've got point A and point B. To get to those coordinates, you're going to have to go through this process. So again, just right here, delta x, delta y. That's when you can find the coordinates between two vectors that are at the origin. Actually, it does work for the origin too. I'll show you that. It's just 0, so it kind of looks like you're not doing it, but you are. So the related position vector is going to be parallel to vector AB. So parallel in vectors means it's going to be the same vector. That's a concept that's going to come up quite a bit. Now, if I wanted to find the magnitude of AB, I think I'll stick with blue there. So remember, the symbol for magnitude is the absolute value symbol. So we can look up here, right? It's going to be the square root of delta x squared, which is x2 minus x1, plus delta y squared. So I've already calculated delta x and delta y. That's just, oops, didn't want to do that. Just 3 and 2. So 3 squared plus 2 squared. Now depending, like if you need to, right? If you need to get a value for that, you can take the square root of 13. Or you can just leave it like that and maybe just kind of like get a value, maybe to one decimal place if you need it. And we say magnitude is root 13 units. And that is how you find the magnitude of a vector. Now you might think, well, what about just a regular position vector? Okay, let me draw a quick little grid here. Okay, well, let's do some negatives. So maybe let's go -2, 1. Is that what that is? Yeah. Okay. So -2, 1. I got this vector here. So when I go from the origin, let's say that's P. So position vector OP is -2, 1. Okay, well, where did it start? Where did the tail start? Because if you want to go delta x, delta y, right? x2 minus x1, y2 minus y1. Well, the tail was at the origin, 0, 0. And then it ended up at -2, 1. So you can go through this, right? So we're going to be -2 minus 0, which is -2. And 1 minus 0, which is 1. So if I'm going to find the magnitude, using that distance formula. So -2 squared plus 1 squared. So that's going to be 4 plus 1. It's going to be your 5 units. Now you can do that, or because it's a position vector and you're just subtracting what it comes down to is 0, you could just kind of like automatically go here. Like you don't have to write all that out because it is the position vector. Oops, sorry about that. You know delta x is just going to be the x coordinate squared, and delta y is going to be the y coordinate squared.